All right, welcome to our first lesson. We're going to talk about percent. Percent is a very important concept. We'll be using it a lot, so pretty much every chapter there's some sort of percent question. It's very useful to know. So for example, have you ever looked at discount when you shop? When an item is on sale for 20% off, how can you calculate what the sales price is? This is just one example of how percent is used. So let's look at the definition of a percent. X percent literally means X out of 100. So percent means per cent. Cent represents number 100. So percent means out of 100 or per 100. It is usually used to indicate a part of a whole. The whole amount is usually known as the base. So for percent, like 100 is the base amount. Different ways to represent X percent are. So we can think of X percent as X out of 100. In terms of calculation, is X divided by 100 or X over 100? Like as a fraction is X over 100. Like mathematically, fraction X over 100 and the division X divided by 100, they're the same thing. And in words, it translates to X out of 100. This is all representing X percent. So for example, when you have something that's on sales for 20%, what that means is 20 out of 100. How do you actually calculate that? Is 20 divided by 100? Or it could be 20 over 100. So these are just different ways to saying 20%. So 20% off means you get $20 off out of $100 worth of merchandise. So that's the concept of the percent. In actual calculation, we need to convert percent into decimal. So a lot of times you're going to calculate a bunch of different stuff with percent. And when we write percent, we write it with a percent sign. But when we actually do calculation, we're going to have to convert that into decimal without a percent sign. And we can do it in two different ways. We can divide the percent by 100. Again, percent means out of 100, so you're literally dividing by 100. Or shortcut way maybe is move the decimal point 2 place values to the left. So for example, if I want to convert 20%, if I have to use 20% during my calculation, the way I can, how do I actually use that? I can do 20 divided by 100. If you calculate that out, you're going to get 0.2 without the percent sign. Or basically 20%. There's no decimal, so when you have no decimal, it's always at the end of the whole numbers. 20 whole number is 0. After that, there's a decimal. So if I were to use this part B method, I'll move two places to the left. 1, 2. So it'll be just 0.20. Sometimes you can write it as 0.20. Right? So either way, we get the same answer. So that's how I'll convert percent into decimal for calculation. So let's look at number 3. It says, how do we convert decimal into percent? Basically, how do you go back, right? So if I want to convert 0.2 into percent, basically either I multiply by 100. So just the opposite of what we just did. Or I can move my decimal point 2 places to the right. So this is how I go back and forth between percent and decimal. Here I'm going to do a few problems in number 4 and number 5, and I'm going to have a pause and finish the rest of it. So let's look at for part B, number 4, part B, 50%. So 50%. Again, how do I convert that into decimal? I can do 50 divided by 100. If you calculate that out on your calculator, I'm going to get 0.5. If I want to do it the kind of shortcut way, again, 50%. 50 is just whole number. So decimal is at the end of the whole number. So decimal is like invisible there, but it's actually there. So I'll move it 2 to the left, 1, 2. So I'll get 0.5, which is basically the same thing as 0.5. So either way, I get the exact same answer. And These numbers are pretty convenient numbers to remember, 0%, 50%, 100%. So that one you can try to memorize that as well, but you can always calculate, obviously. Let's look at number 5. Let's look at part E. It's 1/4. So what I can do is I can use my calculator to do 1/4 or 1 divided by 4. Again, 1/4 fraction is basically the same thing as a division. So when I actually try to calculate 1/4, I'll do 1 divided by 4. If you do that, the calculator will give you 0.25. Again, this is decimal. I want to see if I can convert that into percent. So basically, I'll kind of do the opposite way. So either I can multiply this number by 100, or I can move my decimal 2 to the right. So let's do a shortcut way. So I'm going to move 2 decimal point 2 places to the right. So here's my decimal now. I go move to the right. So 25 point. So basically that's 25 point percent. I can drop the last point. So that's that. So I'm gonna have a pause and finish the rest of number 4 and number 5, and let's look at let's meet back at number 6. All right, let's look at number 6. Now we're gonna talk about how do we answer some of the interesting questions involving percent. So when we are working with percent, one type of the question we'll see a lot involves X% of something. So example we saw before, 20% of whatever you're buying, right? So a lot of times it's formatted as a percentage of something. You get 20% off the regular price. Or if you're paying a tip or something, you usually pay 15 or 20% of the bill that you get, right? So a lot of times the percent problem has structure of percentage of something. So we can kind of approach it in 2 different ways. If you see percent of something, so that something is called the base. So it's percent times base. So percent of something, I'm going to highlight of, translates to multiplication, right? Again, convert percent into decimal for actual calculation, right? For actual calculation. So for example, if I have 20% off of the computer, this computer is $500. What does that mean? That means is 20% times 500. So 20% converted to decimal is 0.20 times 500. If I calculate that out, you're going to get 100, sorry. So what that means is $100 is the discount you're going to get. So if the price says 20% off discount of computer that is $500, basically how do they calculate the discount? You go 0.2 times 500, that's the discount. So this is like a typical example of question where you have a percentage of something. So that translates to percentage times the decimal. So times, highlight that, right? The second way to approach a problem is slightly more complicated, but this is useful when we do not know the base. So what we can do is we're going to form this thing called proportion equation, and this is, we're going to solve equation. I know some of you guys are like, what equations? I think this is not algebra class. We're going to do like just few types of equations. So this is one type which is pretty useful. So if you're not too familiar with algebra, don't worry too much. We're going to go over it with you. So let's see. So let's say we have X% of something. So again, X% is X over 100, right? Then we're going to set it as base. Notice that 100 corresponds to the base, so I'm going to put the base on the bottom, and portion corresponds to X, so I'm going to put X on the top. How do I solve that? You do by basically do cross multiplication. So I'll multiply these 2 cross, and I'll multiply these 2 cross, and then set it equal to each other. So it'll be X times the base is equal to 100 times the portion. And basically when we solve for x, I want to have x by itself. So this is my first step. Second step is you divide both sides by base. Both sides by base. Then basically we'll have x is equal to a bunch of stuff here, right? It'll probably make more sense if I actually do example here. So let's look at number 7, part A. 230 out of 400 voters survey said they will vote in the next election. So I noticed that it's like something out of something, right? So I feel like whatever is out of is going to be the base. So I notice here this is going to be working as my base. So I'm going to kind of set up, I'm going to try to do it the proportion equation way. So they say 200 out of 400 voters. So not every voter said they were going to vote. So only portion. So 230 is going to be playing the part of the portion, and 400 is going to be our base. So I'm going to write it like this: 230 and 400. Notice my base goes to the bottom, and the portion goes to the top. And for percent, I don't know what the percent is, so that's x percent, and then 100. Again, for percent, 100 is going to be just always the base, and next I'm trying to find what percent it is. So I'm going to set it like this. Then I can do cross multiplication and cross multiplication here. So I'll get x times 400 is equal to 230 times 100. So x times 400, I'll do 230 times 100, so I get 23000. My last step is I'm going to divide both sides by 400, because think of it as I'm going to try to get x by itself, so I need to kind of get rid of 400. 400 is multiplying to x, so what's the opposite of multiplying by 400? Dividing it, so I'll divide both sides by that. All right, as a result, I get basically x is equal to 57.5. So basically that means 57.5%. So x is 57.5, so 57.5 out of 100, that means it's 57.5%. So my final answer is 57.5%. Again, just to see if my answer is reasonable, 200 out of 400 will be half, because half of 400 will be 200. So half is 50%. 230 is just a little bit over 50%. So here my answer is 57.5%. It wasn't like 90%, it wasn't like 20%, it was just over 50%. So it kind of makes sense. The answer is 57.5%. All right, I'm going to do one more in this number, and then I'm going to have you finish the rest of it. Let's look at part B. The sales rate, tax rate in Pasadena is 10.25%. If you purchase $210 textbook, yikes. How much is sales tax? So again, this is another typical example of a percentage of something. So when you pay for textbook, they'll charge you 10.25% of your textbook price, which is $210. Again, how does it convert? I'm using method A. Convert 10.25% into decimal. Again, you can divide by 100, or you can just move your decimal 2 to the left. So 0.1025 times 210. Again, of translates to multiplication. And when you multiply this out, you get 21.525. So basically, your tax is going to be $21.525. Here, this is a little sticky situation, because in real life we don't go below 100th, means the pennies. So if something is $21.525, what does that mean? So we're going to round off. So with money, usually you're going to round off to the nearest penny, which is the 100th place value, which means like 1, 2 place value after the decimal. So what I have to do is I have to look at the next number, which is 5. And then if it's more than 5 or higher, then I'm going to have to round up. If it's less than 5, then I'll just keep it as it is. So here I'm going to have to round up to $21.53. So that's the tax they're going to charge you at the cash register. All right, I'm going to have you finish. I'm going to have you pause and finish the rest of the number 7. I'll meet back at number 8. Okay, and let's look at some further application of percent increase and decrease. Sometimes question has phrases like the amount has gone up or gone down, increased or decreased by X%. For example, the wages for workers has gone up by 2% or gone down by 5%, or the number of coronavirus cases has gone down by 20% or gone up by 20%, whatever. That means the value started from a certain amount, which is called the initial amount, and ended up as some other amount. Usually we need to identify two quantities. So the first quantity is the base amount. So base will be just the initial amount. Initial. So what that means is what you started with, which is the initial amount, is going to be your base. And then we have to look at now a thing called absolute difference, or just difference, will be the final amount minus the initial amount. This amount is also known as the absolute change. Sometimes it's called difference, sometimes it's called change. So for example, if the minimum wage was $13 before and now it gone up to $15, $13 will be my initial amount and $15 will be my final amount. So from 13 to 15, it went up by 2. How do I calculate that? Is final amount 15 minus 13, which is the initial amount. So $2 is called the absolute change or absolute difference. And how do I find the percent change? Will be just the absolute change divided by the initial amount. So if your minimum wage has gone up from 13 to 15, the increase amount is $2, which is the absolute change. So the percentage increase was 2 over 13. So convert that into percent, then that's your percent increase. If the amount has increased, that means the ending amount will be higher, right? Went up, and vice versa. All right, I'm gonna try one of number 9s, and I'm gonna have you finish the rest of number 9. Let's look at part D. The number of wild species in a certain region has gone down from 123 to 87. So they used to have 123 species, now it's only 87, so obviously it has gone down. What is the absolute change number of species, and what's the percent change in number of species? So absolute change will be just final amount minus initial amount. So notice that the final amount, which is the ending amount, right, minus initial, so it would be 87 minus 123, which is negative 36. It's negative because it's gone down, so 36 species are gone. So what's the percent change? Again, the initial amount is going to serve as our base amount. So basically it's negative 36 over the base, which is 123. So if you calculate this out, you're going to get 0.29, negative 0.2926, ... Usually with percent, I go 3 digits. So I'm going to round off to negative 0.293. So again, if I want to convert that into percent, I can multiply by 100, move my decimal 2 to the right. So that's 29.3%. Negative. It's negative because it's gone down, right? Here, you could have kind of ignored the sign, the negative and positive. If you just look at the 36, I could have just done 36 over 123, and then you basically get the same answer, but positive. So that's 29.3%. And you can just say, well, it's gone down. It's clearly things has gone down. So you can say it's decreased by 29.3%. You can just say that also. Either way, it'll be fine. All right, I'm gonna have you finish the rest of number 9. We'll meet back at number 10. All right, for number 10, we're comparing two things. I want to say if like one number is certain percent bigger than the other. So this is a percent comparison. For a phrase like XA is X% larger than B, we'll use the second part, something something then something. So this second part is going to be the base. Again, in order to come up with the percent, we need to kind of figure out what the base is. If the phrase like A is larger than B, then b is going to be the base, what we are comparing to. Just like percent change, we can find the absolute difference by a minus b. So again, b is the base. We can find the percent comparison by the absolute difference over the base, which is b, just like the percent change. Shortcut, we can just go without doing the absolute difference a minus b. We can just kind of do a over b and then compare it to 1 to find the percent comparison. Let's look at number 11 here. California's population is 35.9 million and Texas's population is 28.7 million. In terms of population, California and Texas are number 1 and number 2. Compare the size of the two populations. So first, absolute difference, 35.9. So again, is larger than Texas. Notice that is something than Texas. So Texas is going to be my base for this problem. So 35.9, which is California, minus 28.7. So if you look at the difference, it's 2.7. There's a 7.2 million population difference. So that's the absolute difference. So 7.2 million larger than Texas. But what percentage is that? Again, we're using Texas as base because California is larger than Texas. So this is my base. So I'm looking at the difference, which is 7.2 divided by 28.7. When I calculate this out, I get 0.2508 ... Usually I'll do 3 digits, so I'm looking at 8. I'm going to go up. So 0.251, so 25.1%. So 25.1%. So California is 25.1% larger than Texas in terms of population. If I kind of do shortcut way for the percent comparison, I could have just done, well, can I just do California 39.1 over Texas 28.7? When you calculate this out, you get 1.2508 something. So again, 1.251, I can round off. Remember, 1 is just 100%. So I'm looking at this. This is like 125.1%. So 100% means exactly the same. If it's more than 100%, that means California is bigger. If it's less than 100%, that means California is smaller. Here I notice it's like 125.1%. So I can say it's bigger by 25.1%. So here I can go back and say, well, it's 1.25. I'm comparing that to 1, which is 100%. So that means it's 25.1% larger, right? So I can argue that also. So I can kind of do it in 2 steps, or I can kind of do it in 1 step. All right, I think this is it. I'm going to have you finish the rest of the problem. I think that's it for this worksheet.